Hello everyone, this is class 12th, chapter 5, lecture number 4, homework solution. In lecture 4, the homework given to you was exercise 5.2, question number 1 to 10, out of which I am going to discuss some of the solutions. So let us start with the first question, which is here, question number 2 of exercise 5.2. Here we have to differentiate the following function with respect to x. So we will write d by dx of, that means we are differentiating cos of sin x with respect to x. As you can see, it is a composition of two functions, one is cos and another is sin. So chain rule is to be applied. First of all, d by dx of cos of sin x. As you all know that differentiation of cos x is minus sin x. So we will write minus sin. The angle is sin x. Then we will differentiate sin x. So differentiation of sin x will be cos x. So the answer for this will be sin of sin x into cos x. Clear? And at last when you go for x, it will be 1 only. So this is how you are going to solve the questions. Let us go to another question, which is question number 4 of exercise 5.2. In this, you have to differentiate secant of tan under root x. Right? The angle inside secant is tan under root x and the angle inside tan is under root of x. So you will write d by dx of secant into tan of root x. So you know very well that differentiation of secant x is secant x into tan x. So we will write secant, instead of x what do we have? Tan root x. Secant x into tan x. Then we will differentiate. Right now we have just differentiated secant function. Now we will differentiate tan root x function. So we have secant x. Just a second. Okay, so I'll write all the things as it is. Secant x into tan x. Now you know very well that differentiation of tan x is secant square x. So it will become secant square root x. Now after this we will differentiate root x. And you know differentiation of root x is 1 upon 2 root x. So in the statement only I am changing that differentiation of root x then will become 1 by 2 root x. So this will be your solution for the question number 4. Let us go to the next question. Here comes question number 6. As you can see in this we have two functions. Let us consider one as u, another as v. So you know the product rule, d by dx of u dot v, we know u into differentiation of v plus v as it is differentiation of u. So let us apply this formula here. You will write d by dx of this complete function. That means first you are going to take what? Okay, let me write the question itself. Cos of x cube into sine square x5. So this is how we have to do it. So u as it is. So this is u. We will write u as it is first. And differentiation of sine square x to the power 5 plus, now v will be as it is. So sine square x to the power 5 as it is. Differentiation of, we are writing cos x cube. Clear? Let us differentiate them. Cos x cube into differentiation of sine square. So you know that differentiation of, if we have x to the power n, we write it as n into xn minus 1. So first of all you have sine square x to the power 5 will be first to sine of x to the power 5 because the power will be reduced by 1. So it is square. Now we will be left with 1 only. And we will do what? D by dx of right now we have done of power function. We will do for sin x to the power 5. Clear? And this side we have sin square x to the power 5. Now d by dx of cos of x cube. As you know, differentiation of cos x is minus sin x. Clear? So right now we have done for cos. Now we will differentiate for x. Clear? Doing this now, what we will write is, we will write cos of x cube, this 2 I am taking in front, sin x to the power 5 into, now do for sin of x to the power 5. Sin of x to the power 5, you know very well the differentiation of sin x is cos of x to the power 5 into, you will now differentiate what? X to the power 5. Here you have sin square x to the power 5. Now see, here is plus, here is minus. So what will come here? Minus only. Clear? Sin square x to the power 5 into sin of x cube, and of x cube, the differentiation will be 3x square. Clear? Now the only thing left in the question is to do the differentiation of x to the power 5. That you can add in the last step. You will be writing. So what you will be writing is 5x to the power 4. That's it, you need to add in the last step and the question would be done. Clear? Let us go to another questions now. In this question, we have to differentiate the function with respect to x, and the function given is 2 into under root of cot of x square. So 2 being a constant function can be taken out, and it is like this. So 2 into d by dx of under root of cot of x square means the value or the power of this function is half. Applying the formula, we will get 2 into half will come in front and the power will be half minus 1, which is minus half. So in the denominator only I can write cot of x square. Now we have done of the power function. We will do now for cot. Cot of x square. We know very well this 2 and 2 will get cancelled. You have 1 upon under root cot of x square. Now you know the differentiation for cot is minus cosecant square x. So minus cosecant square x square. Now after this you are going to write differentiation of x square. And you know very well that the differentiation of x square will be 2x. So just at the end we will write 2x. Now you can leave the answer in this form also, or what you can do is you can simplify this expression. So I'll tell you how to simplify. You actually have what? 2x upon, see I'm writing these things only. So you have minus of 2x, and then you have here is, yes, minus cosecant square x square. So we will write minus is already written, cosecant square x square, and denominator you have under root of cot of x square. So when you simplify it, you can just convert all the things into sine and cos. So cosecant square x square will be written as sine square x square, and this can be converted to cots of x square upon sine of x square. Also it can be written as sine square x square can be written as sine of x square into sine of x square, because we have a square of this complete function. And in under root we already have cos x square and sine x square. Clear? Now what we can do is, just to see, we can write now minus 2x sine x square. If I take this sine x square inside the under root, it will be sine square x square, right? Sine square x square, because when you take it out, you will be getting sine of x square. into you have cos of x square divided by sine of x square. So one sine and one sine will get cancelled. You have minus 2x upon sine of x square into under root you have sine x square left and cos of x square left. What you can do is multiply and dividing by 2. So this under root 2 will get here. So you will get 2 under root 2x divided by sine of x square, and inside the root, as you can see, you're getting 2 sine x into cos x, which is sine of 2x. So sine of 2. X is what? X square. So this can also be the answer for the question, right? So don't get confused when you get this as the answer. Your answer is also correct. You have to just simplify the answers and then write. Clear? Let us go. Now these are all the questions of chain rule. Now I'll discuss questions on differentiability of the exercise 5.2. Let us see how we do them. Here comes a question where you have to tell or prove that the function f given by f of x in modulus x minus 1, where x belongs to real number, is not differentiable at x equals 1. So what is our c here? Our c is 1 here. Clear? So for solving it, let us first break the function. So for all the values which are greater than or equal to 1, what is the value for the function? As you can all think, so it will be a positive one only, right? When you write x as less than 1, the function will be negative, minus x minus 1, or I can write it as 1 minus x. Clear? Now at point C, which is equal to 1, we have to check. You very well know the formula as told in the previous lecture for LHD and RHD. Right? So we will just solve LHD and RHD and see whether the function is differentiable or not. We are going to prove it. Actually, you know that it is a modulus function. At 1, we will have a sharp edge, a corner point of the graph. So the graph will not be differentiable. There multiple tangents can be drawn. But to prove it and to show it, they're asking us to prove it. So we have to go with the complete procedure. So let us write the LHD and RHD. So first I'm going to solve what? LHD. So let us solve the LHD. Here LHD I am writing. Okay. So what is the formula? Limit at what we have to check? At 1. So in LHD 1 minus will come. Clear? Then what is the formula? F of C minus H. So 1 minus H minus f of C, which is f of 1, divided by minus H. Should I write LHD? RHD also? Let us write it together. It will give a better understanding to us. We will write limit x tending to 1 plus, right? Or if I write it, if you are not writing in H form, just let us write simply. So what do we write? F of x minus f of c divided by x minus c. This is actually the formula. So for 1 minus, when we check and we change the limit to h tending to 0, now we can directly write 1 minus h minus f of 1 divided by, now see, you will write 1 minus h minus 1. So you will be left with minus h. So this is the thing which I wrote earlier. So using this formula we have written. Now in RHD, when we solve, what should I write? You just see, limit h tending to 0, f of 1 plus h minus f of 1 divided by h. Let us decide the function to be taken for LHD and RHD. Fine. So for LHD, when x is less than 1, the function to be taken is 1 minus x. So let us just write the function as 1 minus x. Clear? And for RHD, the function that we will be taking is x minus 1 only. Clear? Now what do we have to calculate? 1 minus h, f of 1 minus h. So f of 1 minus h will be 1 minus 1 minus h. 1 minus 1 plus h. So when you cancel, you are just left with h. Let us calculate f of 1 also. In f of 1, the function is 1 minus 1. So 1 minus 1 will be 0. So f of 1 here is 0. So let us put these values in this formula. So when you do that, so let us write them here. So you will write the limit h tending to 0. F of 1 minus h is coming as h only. H minus f of 1 is 0 divided by minus h. So when you cancel them, you get the answer as minus 1 for LHD. Now just to see for RHD, what you will be getting is, first of all, you have to calculate f of 1 plus h. So the function is x minus 1. So what will be f of 1 plus h? You will be putting 1 plus h minus 1. So the answer is h here. And what is f of 1 you see? F of 1 will be 1 minus 1, that's 0. Just put the values in this formula now. Here we will be putting it. So limit h tending to 0. F of 1 plus h is h only, minus 0 divided by h. So when you cancel them, you get the answer as 1. So you see, LHD you are getting the answer as minus 1, but in RHD the answer is coming as 1. So LHD is not equal to, left hand derivative is not equal to the right hand derivative. Hence this function is not differentiable. Similarly, the other questions of the exercise would be done. I hope this is clear to you. Now let me explain the next question, which is important, which is related to the greatest integer function. Here the function that is given to you is greatest integer function, as we have already discussed in other lecture. Now they are asking you to prove that this is not differentiable at x equals 1 or x equals 2. The only thing to keep in mind in this is, just to see here, I'll just give the example, the rest you can solve it yourself. So suppose I write it as, it is greatest integer x, right? It is lying between 0 to 3. Suppose at 1 you are checking. So 1 minus and 1 plus I will be telling. Just see. If you write 1 plus h, you will be getting the answer as 1.000 something. So the answer for this will be 1. But when I write 1 minus h, right? So it is what? 1 minus 0.0000 something. So the answer will be 0.9999 like this. For this the answer is 0. So you need to be very careful when you write the answer for 1 plus h and 1 minus n, and the question can be simply solved. So I think the homework questions are clear. You can do this question yourself. It was it just needed a hint to be given. So that's all for this lecture. Thank you so much. Bye.